Hi students, welcome to my YouTube channel SADHIK Physics. We are learning the physics very easily through my channel. So recently we started the ray optics. No? In that one more topic we are taking, that is ray optic dispersion of white light. So what is this dispersion? No? Right? You can see that formation of the rainbow, right? So what will happen now, that white light is coming and falling on a droplets, no? So therefore the light is splitted into different colors, right? So you will see a lot of applications of this dispersion of our white light. Why this white light will disperse, and right, this all the things no we'll discuss in this topic. Also we'll go for some different model questions also in this topic. No? Clear? Now let us see what is this dispersion. Dispersion of white light. We will see the dispersion of our white light. No, white light is nothing but is a combination of different colored light rays. So that's why in this world, no, therefore you are able to see the different colors, no, because our sun is giving us a white light, right? So therefore here, suppose if you want to see the leaf, that green color, you will be able to see the green color, right? So because of due to the chlorophyll, some pigment will be there, right? So if the white light is coming and falling on that leaf, so therefore that leaf, no, what it will do, it will observe all the colors, no, and it will reflect only the green color light rays. That green color light rays are coming and falling on our eyes, no, we feel that we are seeing the green color. That's why, so different colors, no, we are seeing because of due to the white light. White light is nothing but a polychromatic light. Clear? Suppose you can imagine our world now. Therefore, if sun is given as like a only one color light ray, like suppose sodium color, that is yellow color light rays, if you are giving, no. So what are the colors can be able to see it now in this world now? If suppose sun is giving as a only yellow color, right? If you know it, please comment it, no. So if sun is giving only yellow color, no, you would be able to see only three colors. What are that? No, only two colors, no, you are able to see. One is black color. Black means nothing. So right, no color light rays are reflecting to us. So only again yellow color you are able to see it. Only the two colors, right? But our sun is giving us polychromatic. That's why beautiful nature, no, you are able to see it. Clear? So therefore here white light is nothing but a polychromatic. Polychromatic, is it right? So that's why in prism last video, no, always we are using like a monochromatic light. Why? Because polychromatic if we are using, no, there is a dispersion will take place now. Monochromatic means single colored, polychromatic means multicolored, right? So therefore here how you are able to see it, no, in the rainbow, in the water drop, anywhere refraction, no, so you are able to see this dispersion now if you are seeing white light. That's why if you are using any like mostly microscope, no, they will be you will be allowed to see only through the one single colored light rays now, right? So this problem is arises even if you are seeing with the using the telescope. Telescope if you are seeing distant object, no, from the distant object only you will be receiving only white light. So that you cannot alter it, no. There again this dispersion you are able to see it. Any refracting surface, no, you are able to see the dispersion. Why? You know that. So here you know the refractive index. Okay. So refractive index, how it is defined now? Defined is nothing but a speed of the light in air or vacuum by the speed of the light in the medium. So in refraction we know it, no, there is no change in the frequency. Therefore here wavelength in air by wavelength in the medium. That means, so refractive index is inversely proportional to the wavelength. That means what you can understand now, or still you can rewrite it as Cauchy's relation, no. So therefore n is equals to some constant plus some other constant by lambda, so plus lambda square, like that, no, you are able to see it. Clear? So therefore you are not able to see, you are not able to learn this one, no. Higher order also it will be there. Right now remember that refractive index is inversely proportional to the wavelength. That means wavelength of your red color is greater than wavelength of your blue color. It is inversely proportional. Refractive index of the red color is smaller than refractive index of the blue color. You understand? No? Clear? Suppose. Now let us see. Suppose if a white light is coming and falling on the, suppose this is one glass slab. This is one glass slab having the refractive index. Now a white light is coming and falling now. This is your white light. White light is nothing but a polychromatic white light. So this is your normal, right? So this is your angle of incidence now. Now you know that white light is contained like a different colors now. That means, so you can apply the Snell's law here no. So suppose you can apply the Snell's law here. 1 into sine I, it will be equal to n into sine r. Clear? So we know it. So therefore sine r can be written as sine I by it is n. Clear? That means it is inversely proportional. Therefore sine r is equals to is proportional to sine I into lambda. That means, so that means here because it is inversely proportional direct. So that means wavelength of your red color wavelength no, right? So is larger than your blue color. So therefore wavelength, right? So refractive index is lesser than, is smaller, right? So wavelength of your red color is larger. So therefore what you can write it now, wavelength is larger means angle of refraction is larger for red color compared to angle of refraction for the blue color. So that means what will happen now, here you know that it is a blue color will bend more toward this side no, and a red color will bend away from this one now. Like so remaining other different colors no will be there in between this one now. Clear? You understand no? So therefore why it is bending no? Because different colored light rays no will be having different refractive index. Different refractive index means different angle of refraction no. So that's why, so white light is falling no, dispersion will be takes place. Where the dispersion will takes place no, at the point where it is incident no, there only the dispersion will be takes place no. So not anywhere in part in middle of this one no, like this. Clear? So that means here if you really see it no, therefore from here to here violet, indigo, blue, green, yellow, orange and red. So like that. So you are able to see the VIBGYOR colors now. I think you got the idea why the dispersion will be able to take place now. Clear? So similarly, suppose if a light ray, if a white light is coming from, so denser medium. Suppose here it is a denser medium is there. So here refractive index no. Suppose here the white light is passing through this one no. So what will happen now? Again the dispersion will be takes place no. Here angle of incidence is same. So different colors no. Now you can apply the Snell's law here. You can apply the Snell's law. N into sine I is equals to, so 1 into sine r. Therefore so sine r it will be equal to n into sine I. N is inversely proportional, that means sine r is proportional to sine I by wavelength, because refractive index is inversely proportional to the wavelength. Clear? Now, so therefore here wavelength of your red color is greater than wavelength of your blue color, but it is inversely proportional. Angle of refraction for red color is smaller compared to angle of refraction to the blue color. Clear? So that means, so what will happen now when a light ray is traveling, so refractive index, wavelength is larger means angle is smaller now. Therefore here there is a red color no, so here there will be a blue color no, like that no. Therefore violet and all this one no, you can able to see it. Clear? Different colors no, you are able to see in between these one no, all different colors. Clear? So how it will be there no? Therefore here there will be a violet, indigo, blue, green, yellow, orange and red. Understand no? So don't confuse in this one no. So right? I think you got the clarity. So therefore, why the dispersion will be able to take place. Now same thing again, one more discussion. No? So we can pass the white light through the prism. What will happen now? Let us see. Dispersion through prism. Dispersion through the prism. So therefore, here there is a one prism is there. No, this is one prism, right? This is your base of the prism. No, right? So this it will be your angle of prism. Clear? Now in the previous discussion now about the prism videos, no, we used monochromatic, no, but here we will use polychromatic. That means white light we are going to incident here. No, this is your angle of incidence. This is the white light. Clear? So now what will happen now? We know already dispersion, and therefore here only the dispersion will take place. No, so therefore here you know that it is entering into the denser medium. No, so denser medium means what will happen now? Therefore above will be your red color and violet will be your near to the prism. Now therefore this is your red color. No, so suppose this is your blue color. Now these are coming here only the dispersion will take place. No, then once it is comes out here, no, this is your blue color. No, so therefore here it will be your red color. No, clear? So why we are using always where we are telling the blue color and this one? No, why not violet color? No, because violet is not sensitive to our eyes. No, we lowest wavelength or highest frequency which is very sensitive to our eyes is only the blue color light rays. No, clear? So therefore that's why we will be using the we will be seeing the blue color, but here violet. No, therefore here it will be still more, right? So you can rewrite it as here, right? So violet, indigo, blue, green, yellow, orange and red. This is your Vibgyor's colors. No, this is your dispersion. It will be takes place. Now here it will be your yellow, right? So this is here white light is getting splitted into different colors, right? Why it is getting splitted? No, we already know it, because refractive index is depends upon the wavelength. Clear? So this is nothing but our dispersion. No, so now for a small angled prism, no, we can see how much amount of deviation is taken place. No, suppose here this is your white light should come here. No, and this it will be your angle of deviation which is created by the red color, and this is your angle of deviation for violet color. We know for a small angled prism, no, so for a small angled prism, so therefore here angle of deviation, this derivation we already discussed in the prism video. Please if you did not check it, no, please go and check it, this prism video. Whatever the problems are there, no, how to solve very quickly also I discussed in that video. No, so therefore it will be n minus 1 into a. This is your for small angled prism. No, therefore this is your minimum deviation. No, clear? So here we can rewrite it as deviation for red color, it will be equal to, so therefore here refractive index for red color minus 1 into angle of prism. No, clear? So similarly deviation for violet color, no, refractive index of red, your violet minus 1 into a. Clear? So therefore here in this one, no, we can call it as like a dispersion. How much amount of angle on an average you can take it onto this one. No? This is yellow, so you can take it as on an average you can take it here, no, up to this is your this is your average deviation, no, average deviation, and how much amount of this angle which is made, that is we can call it as like a dispersion. So we can rewrite it as dispersion. So dispersion is nothing but a theta, so you can rewrite it as, so deviation for violet minus deviation for red color. So you can substitute it now, therefore, so refractive index of the violet minus 1 minus refractive index of red color minus 1 into angle of prism. So therefore it is minus, therefore refractive index of the violet minus refractive index of the red into angle of prism. So this is, we can call it as like a angle of dispersion. Angular dispersion also we can call it. This is deviation, no? This is, we can call it as like a dispersion. Sometimes one more definition also you can rewrite it as dispersive power. Dispersive power. What is this dispersive power? No? So angle of dispersion per average deviation. So this is, you can call it as like a dispersive power. So what you can write it now? NV, refractive index of the violet minus refractive index of the red into A divided by average value, it will be lies around the yellow color onto this one. No? So refractive index of the yellow minus 1 into A, this will get cancelled out. No? So this you can write down refractive index of the violet minus refractive index of the red divided by refractive index of the yellow minus 1. So this is, you can call it as like a dispersive power. In this one, no, these two are very, very important formulas, no? Dispersion and deviation. This is most important to solve the problems in the topics. Clear? Right? So now we'll see, suppose one more, this was your dispersion was explained by the Newton, no? So at that time one doubt asked by the scientist, no? So therefore where the dispersion is taken place, no? This dispersion is because of due to the prism or because of due to the white light, or these colors are coming from the prism or white light, or these colors are coming from the any denser medium or white light. Therefore that question, no, so was explained, so by using this one, no. So he took two prisms, no, therefore here this is one prism, right? So therefore here, and also one more prism he took it, no, so placed inversely, right? So now white light is sent it, no, therefore this is your white light, no, which is sent back to this one, sent it to this one, no, this is white light. Clear? Now what happens now? This dispersion will take place, no, this dispersion, no, right? So we can take it as like a blue color, no, this is your blue color and this is your red color. So now therefore when it is falling this one now, therefore here what happens now, here it is went like this, no, therefore again here it is coming, no, then again coming back onto this one, no, therefore if it is like a white light. So this demonstration tells that so this white, if this dispersion is given by the prism, no, so therefore here this dispersion is taken place, no, here also further dispersion should take place onto this. Clear? But due to this one, no, due to these two prisms, no, he gave white light and also finally also the white light is coming, no, it is not due to the prism. So this dispersion that is present inside the white light. This was the explanation was given by the Newton. Clear? Now, so these are the some theory concepts, no, we will discuss some problems which are involved for this dispersion. No. Clear? Now let us see. Right, let us see this question. No. Here a glass slab is kept over the various color letters, the red color, yellow color, green color, violet color letters. Okay. So these letters which appears least raised means, so therefore which is going to raise it. Okay, least raised, raising should be smaller now. So which color? So raising, if a glass slab is kept, no, therefore raising means what? We already discussed in the refraction, no, that is nothing but a shift. What is the shift formula? Thickness of the glass slab into 1 minus 1 by n. Clear? So this is the shift we already studied, no? You know that. Therefore here wavelength of your red color is greater than wavelength of your blue color. So but refractive index is inversely proportional to the wavelength. That means refractive index of the red is lesser than your blue color. Clear? That means suppose red color is there, no? Red color is there, no? What will happen now? Refractive index is smaller. That means this n value is small. But it is 1 by n, means this 1 by n value will be large. Therefore this large number is subtracted from this one, no? Therefore it will become smaller. So therefore here if refractive index is larger, so therefore here shift it will be smaller now. Clear? Clear? That means refractive index is larger. Sorry, here refractive index should be small here, no? So that means refractive index n should be small. So if refractive index is smaller, therefore here what you can write it now? This ratio will become larger, no? Therefore this large number is subtracted means, so therefore shift also it will be small. Therefore whose refractive index is smaller here, no? So we know that red color refractive index is smaller compared to all these one, no? Shift it will be the smaller, so therefore red color will be your answer. Directly I got it actually, right? You can test it. So which one will be the greater in this one, no? That means what you can write it now? Greater means, so therefore here if you want to have the shift to be greater, therefore refractive index should be larger. If this is larger, 1 by n of this one, now this will be smaller. Small number is subtracted from 1 means it is larger value. So therefore shift it will be larger. Whose refractive index is larger here? Now violet will be having the refractive index is larger. So therefore violet shift it will be large. This is shift will be least. So as per this question, no? Therefore this is your answer. Clear? Right? Like this you should understand, no? Now let us go for one. Right. I think is visible. If it is not visible also, don't worry. Right? You try to concentrate on my words, no? Then you will understand. Clear? So white light is incident on the glass and air as shown. Shown means here let us, if the green light is just total internal reflection. Total internal reflection means immediately you should get into your mind, that is light ray should travel from denser medium. No? Clear? So suppose let us draw the boundary here. No? This is the boundary. So this is your denser medium. No? Denser means glass. This is your air. Now a white light is coming and falling here. No? This is your white light. Clear? So in this white light, no, what happens now? Here, this is your normal. Here what happens now? If the green light is just total internal reflected, no, then emerging the ray into, then the emerging rays in the air contains. Okay. So therefore here what happens now? Suppose here green light is going like this. No? Clear? So therefore which light rays will come into in this air, no? We want to calculate it now. Therefore here how to solve these problems, no? Therefore let us see. So we'll apply the Snell's law here, no? Therefore n into sin I constant, no? Sin r. Clear? Right? So sin r, it should be equal to, sin I proportional to, so refractive index is inversely proportional to the wavelength. That means the critical angle for this is a critical angle for green color, no? Yes, sir? Therefore green colored critical angle now. So that means this critical angle for the green color no. So therefore more than that, that means here this R should be like a critical angle for green. If it is that means green this critical angle is inversely proportional to here wavelength onto this. That means so if it is angle of incidence is more than the critical angle, they undergo like a total internal reflection. So therefore this should be larger means wavelength will be still more smaller onto this one now. So what is this, you know it now, therefore VIB-GR. So therefore here VIB-GR no, therefore what happens now, green color no, therefore these are the wavelength is smaller, these are the wavelength is larger. That means violet, indigo, blue, these all are having the lower wavelengths. So therefore it is having the lower wavelengths means what will happen now, here wavelengths are lower, so this angle will be more, so therefore if it is angle will be more than the critical angle now. Therefore what will happen now, here which are total internal reflected now, so therefore here violet, indigo, blue, violet, indigo, blue, so violet, indigo, blue will undergo like a total internal reflected now. Green color is going now, yellow, orange, red, therefore this yellow, so suppose here orange, right, suppose here orange and suppose red, yellow, orange and red. So this will go into the air. So which one will go? Yellow, orange, red, this will go into the air. Clear? You understood? So like this questions no, you can expect it no in the examinations. This type of understanding is required compulsory. Now let us go for one more question no. Right. Here white light passes through the prism at of an angle of 6 degree, small angle to prism. If the refractive indices of red color and violet color are given now, so angle of dispersion between them now. Therefore here dispersion angle, what you can write it now, angle of dispersion no. So therefore here it will be refractive index of the violet minus refractive index of the red into A. Refractive index of the violet is nothing but a 1.7 minus 1.6 into 6 degree. How much it will be now? Therefore 0.1 into 6 degree. So 0.6 degree will be the dispersion. That means these colors no will comes in the range of 0.6 degree, that value. Clear? Very simple question. No? We'll go for one more. Now so now prism angle of prism is 6 degree, refractive index of red and white are respective. Okay, dispersive power is asking no. So dispersive power, what you can rewrite it now? So dispersive power you can rewrite it as, so therefore here dispersion by average deviation. Clear? Average deviation. Now dispersive power is nothing but a NV minus NR into divided by, or you can write down average deviation no, NV plus NR by 2, therefore minus 1. So will be your average. So here we took it as yellow, but average you can take it onto this one. So here NV is nothing but a 1.8 minus 1.6. So 1.8 plus 1.6 divided by 2 minus 1. Here what you can write it now, here it will be 0.2. So this it will be how much now? 3.4. 3.4 divided by 2 means 1. This should be equal to 3.4 divided by 2, 1.7. So 1.7 minus 1, so that means 0.2 divided by 0.7, that is nothing but 2 by 7. Clear? Now here what is the use of this or no? You can understand from here no. So dispersive power is independent of angle of prism. Now, you can remember that. So, here a dispersive power is independent of angle of prism. Clear? Dispersive power is independent of angle of prism. Clear? Remember that. Now we will go for one more question now. Yeah. Right. For a small angled prism, the angle of prism is A, the angle of minimum deviation is delta, varies with the refractive index as. Therefore, we should know it, know the graph, no, here. So, angle of minimum deviation for small angled prism, n minus 1 into A. What you can rewrite it now? Therefore, it is refractive index, no. Therefore, angle of minimum deviation, no. So, n into A minus A. Therefore, y is equals to mx minus c. Clear? Y is equals to mx minus c. How the graph it will be there now? Here, so this deviation, no? So this m slope is nothing but a refractive index. Clear? Intercept is nothing but a. This should be your, it should be a straight line graph. Straight line, negative intercept, no? This is like this. Clear? Now tell me what is asking here, no? So, we will see what is asking, no. At point P, the correspond to the mu is equals to 1. Mu is equals to 1 at point P. At point P, so where this x value is equals to 0, right. Here, this is your deviation, no. This is your angle of prism, no. So, at point A, therefore, here delta should be equal to 0, this is 0, therefore, n value will be equal to 1. Therefore, yes, this is your correct answer. Now, slope of PQ is A by 2. No, this is wrong. Why? Because slope of PQ is nothing but a n, refractive index. Right. So, first answer is this one. Clear? Understood, no? Right. Now, we will go for one more question, no? Clear? There are two prisms are combined to form a achromatic combination. No? So, what is this achromatic? That means chromatic dispersion should not be there, no? Right? Achromatic. Chromatic means dispersion will be there, no? Achromatic means so dispersion will not be there. Therefore, he is asking, so this combination is asking no dispersion. Dispersion is not there. Clear? So, therefore, for this one now angle of prism you have to find it. So, therefore, here dispersion due to prism 1. So, dispersion theta due to 1 plus theta due to 2 should be equal to 0. Therefore, no dispersion now. Clear? So, as per this given condition is dispersion should not be there onto this. So, dispersion, what is this formula here now? Okay. So, therefore, here dispersion formula here, no. Therefore, n V1 minus n R1 into A1 plus n V2 minus n R2 into A2 should be equal to 0. Clear? So, then you have to calculate this A2 we have to calculate it, no, taken toward that side. So, just substitute it now, substitute the values. This is 1, so n V1, this one, no, therefore 1.42 minus n R1 1.35 into A1 is nothing but a 4 plus n V2 1.9 minus 1.7 into A2. Clear? In this way you can solve it, no, right? If you really solve for this one, no, therefore here you have to get it now. So here 5 7, clear? So 0.7 no 0.07 into 4, it will be equal to, so this is your 0.2 into A2, this will be minus, A2 will be equal to 0.07 into 4 divided by 0.2 minus. Clear? So therefore if you take it here, no, so this is 0.1 into 2, so therefore you can write it as if you take it here, no, 0.7 into 2, so that means is nothing but a 1.4 degrees. So the prism angle should be about 1.4 degrees. Clear? So but also in this also one more question can be asked, no, what should be the net deviation? No? Net deviation, deviation due to 1 plus deviation due to 2, you can rewrite it as, what is the deviation formula? Deviation formula, so net deviation, so therefore here deviation is n average, therefore n1 minus 1 into a1 plus n2 minus 1 into a2. In this way also you can calculate for the net deviation. Clear? So therefore you can solve the problems, no, for this one. Clear? Now we will go for one more question. No? So let us see here what is given. A ray of light is incident on a thin prism, so again the small angled prism, 3 degree, having the refractive index is 1.4. It is combined with another prism of refractive index is 1.6 to produce the dispersion without any deviation. It should create a dispersion, no, without any deviation. So therefore what is the statement here? No, this statement you should understand here. No, this produces dispersion without deviation. No, that means which is not there? No, deviation, net deviation should be equal to 0. That means deviation is equal to 0 means what? Deviation due to one prism, deviation due to another prism. So therefore it will be equal to 0. What is the deviation now? n1 minus 1 into a1 plus n2 minus 1 into 1 into a2 is equals to 0. So a2 we want to calculate it, no, n1 is refractive index 1.4 minus 1 into a1 is nothing but a 3 degree. So n2 is nothing but a 1.6 minus 1 into a2 is equals to 0. So therefore here it will be the 0.4 into 3 degree, it will be equal to, taken here, no, 0.6 into a2, this is minus. So a2 can be written as, so 0.4 into 3 divided by 0.6. Clear? So this is minus. So therefore here you can write on minus 4 into 3 by 6. This is 2. This is also 2 get cancelled. Okay, sorry. 4 into 3 by 6. 3 1s are 3 2s are 2 2s are. Therefore minus 2 degree. Minus in the this question, no, previous question, what is this minus indicate? No, minus means it is should be placed as inverted onto this. So how the diagram it will be there? No, let us see here how the combination will be there. No, this is your one prism here. No, this should be another one more prism here. No, clear? So therefore here there should be a dispersion takes place onto this. So here it will be the dispersion, no, and therefore here it should come here, no. there should be a dispersion should be there and deviation should not be there in this one. Like this, here this is your A1 and this should be your A2. So that's why we got it as negative value, because it should be kept as inverted one now. Clear? Right? So now let us go for one more. No? Okay. Right? So I think mostly about the dispersion, no? All the different concepts, no? We discussed. So really, if you go through this thoroughly, so dispersion questions more than these questions, no, you cannot expect it now, right? So I hope you learned very thoroughly about the dispersion, no, right? So thank you for watching. Please subscribe to my channel, no, and also share these videos, no, those who really want to learn the physics very easily. Thank you for watching.